Hello everyone, today we are going to explain what we did in the manufacturing lab. At the beginning, we didn't even know how to hold a hacksaw, so in practice 1 we started by getting familiar with measuring tools such as the vernier caliper and the tape measure. With these, we measured a metal cylinder, and later we learned how to use the bench grinder to cut it to a specific predetermined size.
In practice 3, we fabricated a sheet metal box. We started by layout, cutting, and bending the flanges to 90 degrees. We assembled the structure with rivets and finished by engraving our names on the metal, creating a solid and personalized piece. For practice 4, we experimented with hot forging. We heated a flat bar in the furnace until red hot. Using tongs and an anvil, we hammered it to achieve plastic deformation. It was an intense process that required speed and coordination before the steel cooled down. Finally, in practice 5, we prepared materials for welding. We precisely measured and cut steel profiles, removing all burrs. A clean, accurate cut is essential to guarantee a perfect assembly.
In Lab 6, we practiced shielded metal arc welding, SMAW, also known as coated electrode welding. It proved more challenging because it uses a consumable electrode, which would stick to the workpiece or create holes due to the quality of the metal we were welding. In Lab 7, we also welded, but this time using MIG, metal inert gas, and MAG, metal active gas welding, which uses a wire electrode. This type of welding was easier for us, and the workpiece had fewer defects. In both cases, we used the same protective equipment and the same workpiece. The combination of these two welding techniques resulted in this piece. In practical exercise 8, we used the bandsaw to cut the initial workpiece and the lathe to perform roughing, turning, boring, and taper operations. We adjusted the tool height using shims, aligned the tailstock, and reduced diameters according to the drawing. We also performed final finishing to obtain a uniform surface. This exercise reinforced the importance of precision, burr removal, and proper lathe calibration. Practice 9 involved working with the milling machine to square the workpiece, adjust dimensions, and mark coordinates on the X, Y, and Z axes. We used parallels to align the block and 1/2 inch and 1/4 inch milling cutters. We drilled 4 guide points and then machined the letters UDLAP following the marked lines. The practice highlighted the importance of proper alignment, zero reference, and continuous verification of measurements during milling. In the last practical session, we carried out a sand casting process. We prepared the mold by compacting the sand and positioning the pouring system. We melted aluminum to 750 degrees Celsius and carefully poured it into the cavity. After initial cooling, we broke the mold, removed the casting, and cleaned it to remove any residue. This exercise demonstrated how mold quality and temperature control determine the final casting result.